Hello guys, today we are going to learn about Julian numerical. And before we go to Julian numerical, like Julia office here is kind of an application. This number is an abstract type and complex. And then there is another type real, which is abstract, integer, unsigned. This is how a numeric type described in Julia. Now, if we can integers and floating point number that type we deal with most here. There are different types of integer types: int 8, uint 8, int 16, uint 16, then int 64, like this. So one thing you might notice, like you would see, is an abstract. Now abstract type is something kind of an as it is described in Julia, like it is kind of a node, but it doesn't have any value, but it represents. For example, number is an abstract, doesn't represent any value. So you would like to see, like for example, let me show you another example here. Would like to now you see here, for example, you have two boxes. One is stuffed animal. I'm using canva.com. Thank you, Canva, to provide illustrative mode. So like I can show here. So you have two types. If you are a child, and then like you have two types of boxes. One would be stuffed animals, one would be stuffed vehicles. Now this represents your abstract. Doesn't do anything, but it is an your type, like kind of box you are in this all the animal goes. Now dinosaurs, for example, dinosaurs, there can be multiple type of dinosaurs, and it has its own, but dinosaur is a core type and it has some value and everything. This box doesn't have value. This is how, like I would say, to assume like it represents a node, and that node abstract, which is kind of an representation. If you want to see all what all falls under number category, then we can use this one. Now it is abstract type in Julia is a general category or idea of something without specifying its exact details. Example, as I showed you here. Once again, let me bring that. So this is a general category. This is a general category. Has stuffed animal is a general category. Vehicles is a general category, but doesn't specify any good details. So numbers are also considered as general category because it doesn't has any kind of real detail. Real detail lies in our bool and 16. So now let's go back to our number types. For example, if you want to um, minimize this, if you would like to see, let's start with integers. Now if I would like to see, for example, integer is, for example, define a variable. It would type, it is type of Python, it is type of X, and here we have it is int 16. So this is simple way like to determine like kind of um, on system you are, either you are on 32 or 34 bit. Another example is to, for example, we can also do println and then say star, which defines like what kind of system we are in. Now there are other types like unsigned integers and hexadecimal. So if you want to insert an hexadecimal or unsigned integer like x1, let us see what is it. You can see it is uint 8. Now if I would do x equals to 0 to 3, is int 16. This is how like Julia automatically determines like what kind of type we are in. So also happens like we can use it our own type and determine it. Now another is like for example if we want to use for the octal and binary. So octal and binary is are with B and O. So this is a U int 8. If I would like to put this one, the value is 2 in binary. If I would like to print the same thing in our octal mode, is 8, and let me print this U int 8. This is how we have defined. Now there are some other functions like we can also find out like what lies in the maximum like values we can insert. So you can there is type min function like in 32 what is the minimum value, what is the maximum value in 6. This is the maximum value which we can have. So in similar way like if I want to print this is the minimum and maximum value of int 32, and similarly we can do for int 64 if I want. And now for example what after what happens like the maximum determine type max. This is the maximum value of it. Happens if I do plus it goes back to the minus value. The reason is that here it has entered the maximum value and after this it will be like to go back to the minimum value here. This is one thing you can understand this. Even for example in 64 is like 2 raised to 63, and then if we add 2 raised to 64 then it can become minus 1. One way to deal with is to use the begin. It solves this problem. I use begin 2 and then do 60. It gives us this much. I do my want. If you're dealing with this kind of, it is recommended to use begin. Now in general we 4. Okay, now let's go to floating point. Now floating point is the 0 point. Okay, be like my 60. Open 60. So the thing is, see, um, is that when we see the floating point 0, they have equal represent. If we do this, it is true. But when we try to print this one, their values are equal. But when we try to print you would see if the leading one thing we need to understand. Now another thing is that most real numbers we cannot represent exactly with float. Many purpose it is important distance between two adjacent representation floating point, which is often known as machine epsilon. Now epsilon is the function which provides us the distance to floating point. It also gives the distance to the next large. By this one I'm not sure how it can be used in mathematical computer systems. And so it represents the epsilon. Another one in Julia, what we can do, we can use them like quadratic equations, or if you have learned the equations. So for example, if I do that six, I can directly represent this as 2 uh, 2x square minus plus 1. This is 10. Let's see, and like for example, also if you have to write to write some of the quadratic equation this, and we can use the numerical literal coefficient common expressions from math directly, but sometimes like it is not possible. For example, if you would assume like would also a equals to a equals to b, you do a plus b raised to, then it doesn't work that way. Like you might assume that it is a square plus b square plus ab, but Julia doesn't know. So right is to use now ab it doesn't know. Now there is complex number. Julia also represent anyone with like for example I am with it is uh, referred to as complex number. Complex number, then use IM, which is an imaginary, and then we can directly like write is helpful. Another is rational number. Rational numbers, if you see, like they are divisible by, like they can be divisible by until like and results to the example exact ratio. Like if if you want to write complex number, this is 3:1. 9 can be divided by 3, and also divide, hence 3:1. Another one we can use if we do 2 with, so then the value will be same because we cannot divide it. And for 4 it is 1 by 2. So 7 by 3, there is no common factor, then it is 7 by 3. So this is support for rational number which Julia has. Now we can also convert number to integer to float, float to integer. It is as simple like for example, when I 4, this would result in a float value. There is also one float 32. We can what happens anything like it gives us 2 0 0 because of the 32 bit we are trying. And there is another of this precision which we can float 6. Now we can also convert to integers like height, which is, and if you want to, there are other round of formulas which we can use. You can also use int60. One thing you might notice, have this one 2.4. 2.4 int z, it will result in an error, because for int conversion we need an exact sorry about that. So we need an exact int value to convert. So for this we can use the float float and this function rounds off. Now this will round off to the, then there is seal 2.4, seal will round off to the highest value. There is round 6 will round nearest value. So this rounds off toward the nearest minus infinity, the nearest integer. This round, the other one is it would to go through is the integer division. So if we see, we can divide 3, then 3 divided by 3, it doesn't give remainder. That's the thing. 1 by 2, then it is 0.5, is 3.33. Same function returns as the new integer. Another, this is what happens. For example, there is another function which gives us the divisor and remainder. We can use div rem, which gives us quotient and remainder. Use the quotient. Now another function I would like to focus on is the square root. We can directly calculate square root function in cube root. Cube root is also there. So I want to find the cube root of 80, something like this. You need to know like what is the square root of 81. This way we can do it. So like 31, so root of 11. So in numbers we have this, we have focused on integer division, conversion of float to integer, then integer to float, x number, then numerical nothing, getting from 0, minimum and maximum value, how you can primary and external. We need hexadecimal number for this. So thank you guys, and we will meet next chapter, which will be more fun.